Nuclear fusion. This is the reaction between the raw materials deuterium and tritium. The fusion of these two hydrogen isotopes produces the largest amount of energy compared to all other conceivable reactions between light atomic nuclei. The deuterium-tritium reaction takes place according to the following principle. The two atomic nuclei fuse to form a helium nucleus, and additionally, they set free a neutron. This causes a large amount of energy to be generated, which is contained within the high velocity of the escaping neutron. A chain reaction is basically impossible. The deuterium-tritium reaction is fully controlled and can be ended at any time should this be necessary. This is the overwhelming safety advantage of nuclear fusion.
Inside. The first type of thermal energy transfer we'll talk about is conduction. Conduction is the transfer of thermal energy between particles of matter that are touching. It's the transfer of thermal energy between particles of matter that are touching. Things have to touch in order for conduction to happen. So if you were to reach into an oven and grab a cookie sheet, if it was too hot, that would be conduction. You would be like burning yourself because the energy from is moving through a fluid. It's thermal energy transfer by particles moving through a fluid. And that fluid can be gas or liquid. I used to think that fluids were only liquids, but fluid can be gas or liquid. And so I have a question for you. When you look at this pot of boiling water, how is it that this whole pot of water actually gets to a boil when only the flame from the burner touches the very bottom of it? How does that happen? How does the whole thing start boiling? Well, the reason it starts boiling is because of convection. Convection allows the water to circulate. It creates these convection currents that heat up the entire pot. So when you heat up the water that gets heated ends up rising, and then the cold water replaces it, and it creates a convection current. And we see radiation waves coming out of the fire and hitting you. And so you're not touching the fire. It's not conduction like touching. It's not fluid like a pot, sort of like flowing water through a pot. It's you feeling these electromagnetic waves flying through the air and hitting you. The same thing happens in other objects too. It's not just fire. It's not just the sun. It's also everything that actually has any thermal energy, in it. Because a lot of times what happens is that, all the time what happens is that other forms of radiation like gamma rays and UV rays and visible light hit objects, and then the objects absorb the energy from those waves, and then they end up emitting it as infrared radiation. We can see that with infrared cameras. And so if you've ever seen Cops, like the show Cops, or you played some sort of video game where you had night vision goggles, those are cameras that actually can see infrared radiation. And so what that might look like.
Priya lives here in Cape Town with her husband, her kids, and Gran. Naturally, they all use a lot of hot water, and with rising electricity prices and the high demand for energy, her bills are through the roof, and the power cuts aren't helping either. Priya cares about the environment, so she decided to get a solar water heater, but it was expensive, poorly made, and when the sun went away, so did the hot water. It just didn't seem worth the energy. Sol Blazer, the green building company, is here to change all that, with new technology that provides more hot water at hotter temperatures. We build our products around the concept of
have convective currents in there where that air gets heated and cooled, and the air moves inside the building components or right up against it, like around the full window.
This phenomena is known as the greenhouse effect because, like the glass in a greenhouse, the atmosphere traps some of the energy beneath it. The greenhouse effect produces a warmer climate on Earth than would be possible without an atmosphere. In summary, water vapor and carbon dioxide allow solar energy to penetrate Earth's atmosphere but prevent much of the long-wave radiation emitted by the surface of the Earth from escaping to space. This trapping of long-wave energy is called the greenhouse effect.
Heat can be either reflected or absorbed, just like light.
I don't get it.
I better show a demo. Fred, could you turn on the laboratory sun lamp, please?
Okay.
Hey, the temperature's going up.
Now, do you know why?
Because the sun lamp is very hot.
Well, that's right. But look, the thermometer with the black shirt is heating up faster.
So that explains why Mr. Richmond was very hot and felt faint.
That's right.
Just because of the shirt color?
That's correct. The black absorbed a lot of the heat while the white reflected it. Do you know why a white shirt like this looks white to us?
Because it's white?
No.
How could I have missed that one?
It looks white because it is made in such a way as to reflect light and heat. The white color you see is actually reflected light and heat coming off the cloth.
But the black cloth of this shirt is not reflecting any light or heat, is it?
No ma'am, it isn't. It's sucking the heat and light in and trapping it, getting hotter and hotter.
Son?
Yes, indeed. First, let's talk about the heat, since that's really what this case is all about. Now, believe it or not, heat is a form of light.
What?
Here, Mr. Savage, take this flashlight and shine it at this mirror.
I can't see.
And why not?
Because the light is reflecting back into my eyes.
That's right. Now, the important word here is reflecting. Because now, Mr. Savage, I want you to shine the light at this old piece of wood. Okay, good. Now what's happening?
I'm still having trouble seeing.
Very good, Mr. Savage. So where does the light go?
Some of it gets absorbed in the wood.
Absorbed into the wood?
That's right. The light gets absorbed right into the wood.
You mean like a sponge?
Well, yeah, I guess you could say that.
But what does this have to do with...